Hi, I'm Emily. I'm a Calc 3 student, and I'm going to be showing you how to do this problem for one of my exams. So we're going to start off. We have a particle with mass equals 4, and it starts at the origin. So your r of 0 is going to be 0, 0, 0. So that's your initial point. It has an initial velocity of v naught, so we're going to write that here, equals, so it has no x position. It has -1 and then 2. Its acceleration is a of t equals 6t, 12t squared, and -6t. So we need to find its position and momentum functions. So we're going to start off, because we have the acceleration function, we're going to have to integrate that first so we can find our velocity function, which we're going to need for momentum, and then we're going to integrate that again to find the position function, which is what we're looking for. So real quick, we're going to write over here that momentum equals mass times velocity. So this is what we're looking for, and we're also looking for the position function. So we're going to start by integrating our acceleration. So we have, this is going to equal the integral of we also have to add our constants of integration because we don't have a definite integral. So this is going to be C1, C2, and C3. So this is our velocity function, but we were given an initial velocity, so we have to plug that into the equation to solve for our constants. So if we let t equal 0, then we get 3 times 0, 4, or squared, 4 times 0 cubed, and -3, 0 squared. But we also have our constants here. And this all is going to be equal to our initial velocity here, which was, let me write this down here. Which is going to all be equal to 0, -1, 2. So because these are all 0, that means that we have C1 to be equal to 0, C2 to be equal to -1, and C3 to be equal to 2. Now we can rewrite our velocity function with our constants. So we have 3t squared, and I'm just going to combine these two vectors here. So because C1 is 0, then it's just 3t squared minus 1, and then -3t squared plus 2. So we need this for our momentum, but we still need to find our position function. So let's continue to integrate this, and then we can go back and calculate the position and momentum functions at the same time. So now we need to integrate this function again to get our position function. So we have r of t is the integral of v of t dt. So writing in our velocity function, we're not going to integrate it. So here, let me do it down here. We have t cubed plus, and so over here I wrote this separately, but we can write it all in the same vector equation. So plus C1. Here we're going to have t to the 4th minus t plus C2. And then here we're going to have -t cubed plus 2t plus C3. And this is our new position function. So again, like we did for the velocity equation, we were given an initial position, which is at the origin. So if we make t equals 0, then we get the equation, if we kind of just go this way, at 0, and that's going to equal our, and I guess we can make this should be a vector, if we're going to write it this way. So that means that r of 0 is going to be 0, 0, 0, which is equal to, if we plug in 0 into this equation, C1, C2, and C3, which basically means our constants go away. So if our total position function, or with our constants of integration, is going to be, and I'm going to write it over here because we're going to need it for the next part. Let's see. So R of t ultimately is going to be t cubed, t to the fourth minus t, and negative t cubed plus 2t. And then I'm also going to write our velocity equation. We're going to erase all this and then calculate our momentum and position functions. So we still have our velocity is equal to 3t squared, 4t cubed minus 1, and negative 3t squared plus 2. So I'm going to erase all of this, and then we're going to use these two to calculate our position and momentum. So now that we've erased the board, let's find our position and momentum functions. So, well, we already have our position function here. So this is part of our answer here. We still need to find momentum. So we said that momentum equals the mass times the velocity. We were given a mass of 4, and now we found the velocity function. So then we can just write that our momentum function is going to be equal to, we'll write this here, so plugging in the values, we're given 4 times the vector 3t squared, 4t cubed minus 1, and negative 3t squared plus 2. This is a scalar, so we just multiply it throughout the entire vector, and our final answer for momentum is 12t squared, 16t cubed minus 4, and negative 12t squared plus 8. And this is our final momentum function. Like I said, we already found our position function, so that is your answer for this question.